Good morning. We're here to talk about writing that stupid boilerplate Java code, the stuff you got to write every time and you wish it was built into Java. Okay. Actually, what I want to talk about, what I want to get to, is how to override equals properly. But before we do that, actually, I'm just going to do some more basic stuff suitable for beginners, and even if you already know it, you might find a couple new approaches, interesting ideas in it. So we're going to talk about just making a class with some fields, the boilerplate constructor, the boilerplate-to-string, and then overriding equals. That's actually going to be in the next video. And then there's going to be a video after that. Oh my gosh, if we override equals, we have to override hash code. Okay, whew. But for now, let's just look at the very basic Java stuff and realize after you do it a few times, you're like, oh, this really should be built into the languages. And we'll see that in some ways it is. And in some languages, many good languages, this stuff is built in. Okay, so let's go ahead and make I want to represent a book. Okay, so class book. I'm thinking more not so much like one individual copy of a book, but in the publisher's house where they have, oh, here are all the books that we publish, or something along those lines maybe. But anyway, regardless. 1, 2, 3, 4. By the way, this code here compiles. It's just good to note when you're writing your Java. Yeah, go ahead and compile right away. Don't wait. But we want to represent a book. What information do we want to represent a book? I want to keep track of its title, the author, how many pages, and whether or not it's copyrighted. Okay, so our first step again is how do we represent this information? We've already decided there's 4 pieces of information. We're going to bundle them together. We're going to use a class. That's why we typed class. Okay, how do we represent each of those pieces of information? Pretty straightforward, using existing built-in Java types. We wanted to keep track of the title and the author and the number of pages and whether or not it is copyrighted. Okay, great. Title, that sounds like a string. Author, string, sure. Number of pages, that's a little bit of an interesting one. We want to use a numeric type, clearly. Should we use int or double? Standard question you ask yourself, does it make sense to have a fractional amount of pages? So I'm going to go with no. Although arguably say, hey, if this book has 3.5 pages, the last page is only half covered in print. But I'm here more thinking about the number of sheets of paper that are in the book or something along those lines. So I'll go with int. It doesn't really matter. But always ask yourself that question. Don't always choose int or don't always choose double by default. What makes the right sense for the thing you're trying to model, the domain? Okay, is the book copyrighted? We have the Boolean type, which is exactly what we want. Okay, by sure, compile. Make sure everything compiles. No syntax error is good. Okay, Java, even with this class we just compiled, makes a constructor for us. It is a totally useless constructor. It makes an object with totally uninitialized fields. The purpose of a constructor, by the way, I would say, is to make an object with a valid object with constructed fields. Okay, so the default constructor totally fails that Java makes. So we need to write our own constructor here. No return type. Name of the constructor is the same as the name of the class, which would be the return type, which is why we don't mention the return type. Okay, gosh, you need to give me these 4 pieces of information before I can go with it. So you need to give me a title, author, and don't do a lot of thinking here. Don't try to think about what should I call these different fields. We already came up with names for these things, or these different parameters rather. Okay, so what do I want to do? I want to go ahead and assign the 4 fields to these values that got passed in. Now you might be saying, hey, we don't need to do this dot and so on. That's true, but I have a small brain. I need to go ahead and say, hey, whenever I access a field, it's object.fieldName, and I want to know what object I'm accessing the field of. Oh yeah, there's an object of a variable this that refers to an object, one that the constructor automatically generated for me. And so, I'm going to go ahead and say that this dot, it helps for a number of reasons, but if nothing else, it helps because my brain is too small to worry about when do I have a dot and when do I not. It's good defensive programming too, I suspect. Okay, so this is my constructor, works just fine. Let's go ahead and see if I can actually use it. I'm going to go ahead and I could just go ahead and type an interactive thing and call the constructor, see what it does. For tests, I'd like to go ahead and I'm going to have a void method called test where I'm going to go ahead and put certain things. One of the things I want to be able to do is double check that can I call new book of the Cat in the Hat by Seuss, 37 pages, and it certainly is copyrighted. Okay. There we are. I want to be able to say things like that and call that constructor. Make sure I do something. Let me compile this, make sure that works. Okay. Now I can go ahead and I can go over here and just try that. I'm going to paste in that exact constructor I just made. And sure enough, I call the constructor. And I get back an object reference. In BlueJ, I can examine that. Do I need to put it here first? And I can look, sure enough, I have a little object that encapsulates 4 pieces of information, aggregates them. Okay, everything looks good. Okay, so, by the way, if you're wondering here, there's 2 classes here. Book is what I just typed. I actually have a bunch of stuff pre-typed, so I'm going to go back to that pre-typed field now. Great, we have the boilerplate constructor. Let's go ahead and make a toString. Okay, that's going to be a pretty simple toString. But here's an interesting little twist. I'm going to go ahead and have the toString return a string representation of the book, but I'm not going to gear it towards somebody who's like a layperson, an end user. I'm going to gear this towards a programmer. I'm going to have it print something, make sure it encapsulates all the information that's in the book. And here's my fun little tweak. I'm going to make it so that the string that it prints out happens to be valid Java code for this piece of information. Okay, so what do I mean? Here's what I want to say. I want to go ahead and say that if you have this book here, you can go ahead and give it a name if you like. Book B1 gets da-da-da-da. Here's what I want to say. I want to say that B1.toString is equal to here's what I want to get back for this particular book B1. I want to have it be, well, here's what I'm going to do. I'm just going to copy and paste this Java expression. I want this part in blue to be what's returned. Okay, so copy, paste. Okay. Oh wait, I have some weird, oh wait. Okay, the thing that I want to get generated, the string that I want generated needs to have a quote in the middle of the string that I want. So how do I get a quote inside a string? I have to put a backslash here, and here, and here. Okay. But yeah, so if I call B1 and toString, I get, this is the string that this is the string that I want to get back. Starts with the word new and the word book. It's just a string of output, but it's something that if I wanted to, I could copy and paste it into somewhere else in a program and it would be runnable Java code. That's kind of cool. Why not? Okay, so this is what I want. I'm going to do some lowbrow testing here. You should really be using JUnit, especially if your IDE supports it. BlueJ certainly does. But I'm going to be a little bit lower brow here. I'm just going to try to assert this. Okay, and I'm going to run this with assertions enabled. Assert the b1.toString is going to give me back this string here. Okay, so let's go ahead and write our toString. Okay, and this isn't so bad. Need to say public. Why? Up in class object, there's already a toString defined. and we're overriding that method. In fact, you know, Java lets us, this is kind of cool, lets us annotate our program and say, hey, this is an override. And if we get it wrong, if we're not actually overriding, it's going to actually let us know. So, and by the way, if we didn't put public here, we wouldn't be overriding. So, okay. Public, let's see, override, public toString returns a string, takes in, looks like it takes in nothing, right? I just called toString and didn't pass anything. Well, there was something getting passed in. There was this book B1 as an implicit parameter. So here's something you may or may not have seen. I like going ahead and saying, you know, really there is something being passed to this toString. There's a book object. And what should we call this book object? Well, it turns out we don't actually write this. The book gets passed in implicitly. And you know, the compiler gives it a name already. The compiler generates the thing, the book that gets passed in implicitly to this function is given a name. They just chose the name of the hat. They happen to call it this. But it's just a regular variable name. Don't be intimidated by the word this. It's a variable name that the compiler put in there for us. So here's what's happening conceptually. I'm calling toString, I'm getting passed a book. You don't list it there, you list that book in the dot before calling toString, and I better comment this out because it won't actually compile if I say that. But that's what's going on. I'm going to leave it there to remind myself, hey, I'm being given a book. Okay. So, and you know, especially if you're following the how to design programs approach, we sort of have a template for any function that processes a book. And it's pretty lame. It just sort of says, hey, if you have a book, look at the fields you have involved in it. This dot title, this dot author, this dot num pages, and think about what types they are. Think about what functions you might call them. So I'm just sort of thinking, I'm going to do this for any function dealing with books. Hey, if I'm passed in a book, then yeah, look, I'm going to have these 4 pieces of things going on for me. Title, this dot title, this dot author, and so on. See, this dot title is going to be a string, so I'll be, remind myself of some string functions. I might call substring on it, I might call string append on it, string length, who knows. Num pages will be an int, maybe I'll call plus on that, or greater than. This dot is copyrighted as a boolean, maybe I'll call something like if on it. So following this how to design programs approach, we can actually make a template for any book handling function. And this applies equally well to Java as any other language. Any function handling a book is going to look like, I'm going to have a name. I don't know what the return type is, but I'm going to have a name, and then I'm going to have this implicit parameter passed in. And I'm going to have these 4 pieces of information to work with. This gets me started. This gets me past a blank screen, regardless of what function I'm going to have dealing with books. So that's the template for a book handling function. And now we can go ahead and flesh out our own function. I want to return a string. Starts off with what letters? NEW space BOOK space. In fact, all this is going to be what I want to start with. So new book. I'm going to write it like this. So I'll say new book, and then I'm going to go ahead and include the title. In fact, let me just put it like this here. Okay. Great. So the string new book, and then the title, and the author. Oh, except I want a comma between these things. And no comma here. I'm going to finish it up with maybe did I want a space before that closing paren? Let's go ahead and look at what I had in my test case. I did have a space. I got that because I copied it from here. So yeah, okay. Good to know. Good thing we have the test case. We're already thinking about, hey, exactly what spaces do we want and not want in our toString. Okay. Great. I'll do some unorthodox indentation here. In fact, I'll make it more unorthodox. Okay. Return a new book with this, comma, this, comma, this, comma, this. And I could go ahead and run this. We're going to fail this assertion Well, first of all, we have some errors. What are the errors? I didn't mean to have an error. What does it not like about this line? I have a closed paren here with no semicolon. Okay. Compile early, compile often, find those errors. I should have already found that error before even writing my toString. I can run this. It will fail the test case. The string I get back has new book, open paren space, and then the letter T. It doesn't have a quote mark right before the T. So, oh, right. Yeah. So, started to do this and then decided I'd back off a little bit. Okay, there's a quote mark around the title and the author. Yeah. If you're really sort of sneaky and thinking about things, this will go ahead and pass our test case here. Looks like a pretty good toString for what we want. It's not exactly correct. Why? What if the name of the book had a quote character inside of it? Okay? If I had a title of the book and the title itself contained some quote marks. Gosh, think about how you'd have to call the raw constructor for it, and then think about, hey, well, that's the string I want to produce, and then how to get my toString to do that. It's going to be adding some extra backslashes and double backslashes and stuff like that. So if you write a good set of test cases, you'll actually maybe have thought about that before we even wrote our code. I didn't write a good set of test cases. I only wrote one, thought that'd be good. And I'm going to ignore that issue partly because I should then have a helper function that takes in any string and gives back a string that prints as you would want to go ahead and paste it in to get that string. Okay, anyway, we're going to stick with this and call it good. So we've overridden the constructor, we've overridden toString. We've written this here, which I think is interesting. I think it helps understand and demystify this little parameter THIS. It just, hey, there really was a book passed into this method. The compiler just wrote the argument. It wrote that part that I have in comments. It wrote that for us. Okay. So let's talk next about, well, let's just make sure this runs, and then we'll go ahead and go to the next video and talk about overriding equals. Okay, so do this. We're going to run book.test. Non-static method test cannot be referenced. That was a bug of mine. This should be a static method, as test methods are. Okay. Let's get rid of that. Test. And we got no assertion errors. And I really do have assertions enabled. By the way, if you're trying this at home, you need to run Java with the -EA flag or -- enable assertions flag. You might need to go into your IDE and configure how to do that, which I've already done. To make sure that assertions really are working, let me go ahead and say, instead of new book, maybe I'd sort of said new book. This should now fail, this test case, and let's go ahead and try it. Oh yeah, I'm getting an assertion error at this line here, and yeah, okay. So, okay. Next video, we're going to take this and we're going to add on overriding equals, which is not as easy as it sounds, unfortunately. But first, let me just say two other very quick things. Python has this distinction between two different toStrings that are part of the language. Java just has toString. All objects have toString. It's nice. You can always count on an object having toString. In Python, they actually have stir, which is sort of like toString meant for end users, lay people, non-programmers to look at. Then they also have another function, repr, R-E-P-R, for the representation. It's the string version that shows the representation of the object. And that's meant for programmers to look at. And that's sort of more what we did when we went ahead and said, hey, we're going to go ahead and have our toString that returns something that is code that we put right back in. By the way, that little trick is something that I learned myself from Scheme and Racket in particular. So that's nice. The other thing I just want to mention real quick is that I went ahead and had the override tag here. Because I have override, I don't need to have any more javadoc. I don't need to have a little purpose statement. Why? there's already a purpose statement for toString up in class object. And I don't need to repeat that here. So that's why I didn't have that extra information. Okay, now let's go on and look at overriding the next one. Equals.